Good day, everyone. So, in today's class, we'll be looking at projectile motion. And at the end of the lesson, you'll be able to define this word, projectile motion, and some terms surrounding it, like the time of flight, maximum height, range, and so on. And lastly, you'll be able to solve calculation question about this topic. So, let's dive in. So, we're going to start with what a projectile motion is. So a projectile motion is the curved path followed by an object propelled into space, influenced only by gravity and sometimes air resistance. Look at this ball now. This ball is undergoing projectile motion because it has created a curved path as a result of it being kicked into the air. And as it's being kicked into the air, it keeps moving and it takes through a curved path. That curved path is what we refer to as projectile motion. Then, as it's moving also in the air, is being opposed by air resistance and also sometimes by gravity too. So these two things affect projectile motion: gravity and air resistance. Okay, so we want to see the time it takes this ball to get to that place, the time it will take the ball to come down, the range the ball will cover on the ground from where it starts to where it lands. Okay, so you are going to be considering all of these factors. But before we get that, we also want to see that even though the air is moving in the air, we can categorize the movement into two parts, either vertically movement or horizontally movement. Okay, so let the ball move vertically, okay, and then make a curve path or move horizontally. So in the vertical motion part, we believe that it is accelerated by gravity. When object keep moving up, okay, uh, the acceleration of that object is being opposed by gravity. But if an object is moving horizontally, then we believe that the velocity of that object is the same, meaning that the velocity is not changing, just going like this. So those two concepts are important. For horizontal motion, the velocity is constant. For vertical motion, the velocity is not constant. And then it is being opposed by gravity. In horizontal, there is no gravity. So this part that is being created, which is called the curve path, is actually known as the parabolic trajectory. That curve path created is known as parabolic trajectory. Okay? What are the areas of application of projectile motion? In warfare, you could see that the soldiers sometimes the modern weapon they use, they throw bomb, different kind of artilleries. These things are being thrown into the air and they form a curved path. Okay, even the one that we call catapult. So when you take catapult and you shoot it, the stone that is coming out of that catapult, we're going to undergo projectile motion because we're going to take through a curved path before landing. Aside from warfare, in sport as well, we can also experience projectile motion where the athletes, okay, or the sport person throw a javelin. That javelin that is being thrown, it goes through a curved path that we call the trajectory path. Okay, so these two areas of applications are where we can experience projectile motion. Now let's begin to consider some key factors in projectile motion. Number one is the initial velocity. Okay, whenever a body is being launched into the air, okay, it moves with an initial velocity from the point of launching. Okay, look at this ball now. This ball begins to move from this point. At least the ball is moving from initial velocity of 0. U represents initial velocity. So we have initial velocity as one of the key factors in projectile. We also have launch angle. The launch angle is the angle between the initial velocity and the horizontal axis. This horizontal axis here, this blue line, and the initial velocity is this curved part here. Now this angle here, this theta here, is known as the launch angle. It's the angle between the initial velocity and the horizontal axis. Then we have the time of flight. The time of flight is the total time the projectile stays airborne, or the time it takes the projectile. The projectile now is the object that is being launched. It could be anything, it could be javelin, it could be bomb. Whatever is being launched into the air is called the projectile. Now, whenever the projectile gets to its maximum point and it comes down, okay, the time it takes that projectile to go and come down is called the time of flight. So the total time for that object to go up and then come down. The maximum height is the highest point reached in the trajectory. When the projectile is being launched, the maximum point it will reach before it will come down is known as the maximum height. And the last one is the range. The range is the horizontal distance covered by the projectile. When the projectile is being launched into the air, like we see, and we follow the trajectory like this, it goes like that, and then it finally comes down. Now the distance between the point of projection and the point of landing, that horizontal distance is called the range. All of these factors, they are inputted into formulas. Now let's look at the core formulas or equation. Now, in this formula, we have that of range. Range formula is u square times sine 2 theta over g, where the u remains the initial velocity, theta remains the launch angle, g as relation to gravity, and most times is given as 10 meters per second squared. Then we also have the maximum height, which is u square sine squared theta over 2g, and we have the time of flight, which is 2u sine theta over g. Then we can also have time it takes to get to the maximum height. Okay, that one is small letter t. T is equal to u sine theta over g. This one is the time it takes to get to the maximum height. Okay, no, if the projectile is being launched, it goes and come down. The time it takes to get here is called this t. When it now comes down, that's the second, the capital T. Time it takes to get back to the position or to the ground is a time of flight. All right. So let's see one or two questions on this projectile motion. Look at this question here. It says a stone Q is thrown with velocity at an angle of 75 degrees. Please take note that this is 75 degrees, it's in degree, not 750. That means the launch angle is 75 degree to the horizontal. Okay, this is for stone Q. So let's call this one theta Q. Then another stone R is thrown with the same velocity. Okay, that means the initial velocity u q is the same with u r. Okay, so another stone R is thrown with the same velocity but at an angle of 150 degree to the horizontal. So this time around, we are giving theta R to be 150. Okay, this is 15 degrees. Sorry, this take it as 15 degrees. Mistake. So 15 degree to the horizontal. Okay, the range covered by the stone will be what? A greater for Q, B greater for R, C the same for Q and R, D greater for the area of the stone. Now the question you are going to ask yourself is what is the formula for range? Range formula says u square sine 2 theta over g. Okay, that's the formula for range. So now we are going to do it for the stone Q. So we can say that stone Q will be R, range for stone Q will be RQ. RQ now will be equal to UQ squared sine 2 theta Q over G. G is constant, so we can say that. But remember that we are told that the initial velocity of the two stones are the same. All right. So what that means is that if you make this UQ such as the formula here, so we have U square Q will be equal to GRQ over sine 2 theta Q. Okay, but we know that our theta Q is 75, so we can say U square Q is equal to GRQ over sine 2 times 75. Okay, so going forward, we have U square Q equal to GRQ over sine 75 plus times 2 is 150. Okay, now then making your UQ subject of the formula, we have that to be our UQ will be equal to square root in both sides because there is square here. The square root of GRQ over sine 150. Now we do the same thing for stone. We have two stones, stone R. Applying the same formula now. Okay. Applying the same formula, we can easily say that U R, using this same formula here, will be square root of G R R, that's the range of stone R over sine theta, sine 2 theta, in this case 15, so that will be sine, our theta is 15, so 2 times 15, instead of 2 times 75, so 2 times 15, okay, and then our UR there will be square root of GRR over sine 2 times 15 is 30, sine 30. All right, so since two of them are the same, these are equal, so we are going to equate UR with UQ with UR. That's what we're going to do now. Okay, so doing that, we can easily say, okay, let us clear this point. So let's clear this area so we can have a space. So we equate the value. U R and UQ. Okay, so when we do that, so our UR is this, so that means square root GRR over sine 30 is equal to square root UQ, which is the GRQ over sine 150. All right, so we can go forward. Let's read this part. Now that we have equated their initial velocity, since they are equal, the statement made in that question, now let's go by. It said in that question, it said the range covered by the stone, the ranges covered by the stone will be greater for Q. Which one will be greater? Now squaring, when we square both sides, we'll be having our square root to what? To disappear. So this square root will disappear, we square both sides. And then we have GRR over sine 30 to be equal to GRQ over sine 150. And then G cancel G. Alright? So G cancel G. So from here, sine 30 is 0.5. So sine 30 is 0.5. So we have R over 0.5 over, I'm equal to RQ. Let's find out for uh let's find out for sine 150. Sine 150, what would that give us? Sine 150, sine 150. Okay, so we have the 150 sine by calculator here. It's giving us 0.5 as well. So since this is also giving us 0.5, sine 150 is 0.5. So automatically, if the divide both side, if you multiply both side by 0.5, 0.5 will cancel out. That means the range of stone R is equal to the range of stone Q. Okay, so the same for Q and R. The correct option is C. Okay, A is greater for Q, no. B greater for R, no. C the same for Q and R, yes. D greater for the area of the stone, no. Okay, so let's see another question. Here it said an object is projected with velocity of 80 meters per second at an angle of 30 degrees to the horizontal. So the maximum height reached is A 20 meters, B 8 meters, C 160 meters, D 320 meters. Let's now write out the parameters. An object is projected with velocity of 80 meters per second. So our initial velocity U is 80 meters per second at an angle of 30 degrees, meaning that our launch angle is 30 degrees to the horizontal. So the maximum height, that is our h, is what we need to get. So by formula, maximum height says u squared sine squared theta over 2g. That's maximum height, okay, formula. So our u is 80, so 80 squared sine squared, our theta is 30, so 30, then over 2 times g, g is 10, okay. So 80 squared means 6400, okay. Then sine 30 is 0.5, okay, so times 0.5 squared, okay, or we say 0.5 is 1 over 2, so 0.5 squared, okay, for sine 30 is 0.5, so square it, then over 2 times 30 is 20, so 2 cancel 2 here, I mean 0 cancel 0 rather, then we can quickly simplify this with our calculator. Let's just say 2 here 1, 2 here 3, 2 here 2, so we have 320. So 320 multiplied by 0.5 squared, okay. Let's quickly do that. So 0.5 multiplied by 0.5, then multiply by 320. So our result there is giving us 80. So obviously our answer is 80 meters, right? And here we have option A to be 20 meters, option B to be 8 meters, and then option C 160 meters, option D 320 meters. So the correct option is supposed to be 80 meters. There is an error in this option. Maybe if if this one happen to be 80, it will be B. So there's no answer here. So going by calculation, this is the correct answer, 80 meters. All right. So this is another question again. Say two bodies X and Y are projected on the horizontal plane with the same initial speed, but at angle 30 degree and 60 degree respective to the horizontal. Neglecting the air resistance, the ratio of the range of X to that of Y is option A, 1:1, option B, 1:2, option C, 3:1, option D, 1:3. So this is similar to one of the questions we solved. Okay, so I will leave this to you to attempt it and see if you're able to get the correct answer. All right, so we're going to be doing the cutting here. I hope you're able to understand the topic projectile motion today. Thank you for watching and have a wonderful day. Bye for now.